Welcome to AMAC KSSM channel. This is KSSM at Max Form 5 exercise discussion. I'm Madam Wong here. Exercise 8.3. Number 1. Determine the velocity function v in terms of t for a particle that moves along a straight line in each of the following using differentiation. So you can see we are given all the displacement function here and we want to get the velocity function. Therefore, we need to do first derivative for the ds dt. Okay, so a s equals to t times 2 minus t in completely square. So we will first expand the completely square bracket. We get 4 minus 4t plus t squared. And the t outside will times each of this and we get s equals to 4t minus 4t squared plus t cubed. Then with this, it's easier for me to do differentiation. So v equals to ds dt. So I will differentiate term by term. 4t after differentiate will get 4. Negative 4t squared, 2 times negative 4 here, so I get negative 8. And t from power 2 become power 1. And we don't write for the 1. T to the power of 3, t cubed, okay, we'll bring down the 3 and the power of t minus 1 become 3t squared. So the v is 4 minus 8t plus 3t squared. B, s equals to 16t minus t squared. So the v is ds dt. We just differentiate term by term. We get v equals to 16 minus 2t. C, s equals to 2t cubed minus 4t squared plus 2t plus 1. So v equals to ds dt and we do differentiate term by term. So we get 6t squared minus 8t plus 2. So this is the v we get. D, s equals to t cubed times 3 plus t completely square. So again, with this, okay, I don't expand the bracket. I can use the product rule in differentiation. Our first du dt, okay, which is I differentiate the t cubed become 3t squared times with the 3t completely squared. Sorry, 3 plus t completely squared. Plus the t cubed remain times with the differentiation of t 3 plus t completely squared become 2, 3 plus t power 1. And don't forget the 1 because in front of t the coefficient is 1. Alright, so simplify this or expand this, okay, then we will get 3t squared times 9 plus 6t plus t squared plus the 2 times 3 and times t cubed. So we get 6t cubed, 2 times t times another t cubed. So we get 2t to the power of 4. There, again, we expand this. We get 3t to the power of 4 plus 18t cubed plus 27t squared plus 6t cubed plus 2t to the power of 4. So simplify this function. We get v equals to 5t to the power of 4 plus 24t cubed plus 27t squared. E, s equals to t times 2t squared minus 9t minus 5. So the t times inside each term, I get s equals to 2t cubed minus 9t squared minus 5t. Then v is the ds dt. We get v equals to 6t squared minus 18t minus 5. F, s is 1 over 3t cubed minus 3t squared plus 5t minus 2. So v is the ds dt. Therefore, v is t squared minus 6t plus 5. Question number 2. Determine the acceleration function a in terms of t of a particle that moves along a straight line for each of the following. So a, we are given a displacement function. So with the displacement function, we will first get the v by first derivative. So we get v equals to t squared minus t plus 4 from here. And then from the velocity function, we want to get the acceleration function. We do another times of derivative. So we get 2t minus 1 plus 0. So the a equals to 2t minus 1. B, again we have a displacement function. S equals to t cubed minus 5t squared plus 7. Get the V. By first derivative, we get 3t squared minus 10. A equals to dv dt. So again, with derivative, the 3t squared minus 10, we get 6t minus 10. So the A equals to 6t minus 10. C, S equals to 8t minus 2t cubed. Get the first derivative to get velocity function. We get 8 minus 6t squared. And from the velocity function, we differentiate with respect to t to get the acceleration function, which is A equals to negative 12t. Then D, we'll see this is already the velocity function. Therefore, to get the acceleration function, we just do first derivative with respect to time. So we get 2, bring in front. Then the brackets remain with the power minus 1. And don't forget to time the coefficient in front of the t, okay, inside the bracket. So we get negative 6 times 5 minus t. That is the function of A. E, V equals to 3t squared minus 1 over t. So we change the 1 over t become t to the power of negative 1 plus 4. So to get the acceleration function, we do first derivative. A equals to 6t, and then negative times negative 1, so we get positive t to the power of negative 1 minus 1, and I get negative 2. And the 4 after derivative, it will become 0. So write back the function A, we get A equals to 6t plus 1 over t squared. F, V equals to 6t cubed minus 4t squared. Minus 4 over t squared. So again, the over t squared become 4 to the power of become t to the power of negative 2. So A is the dv dt. We do first derivative for the function V. So we get A equals to 18t squared, and then negative times negative, we get positive 8t to the power of negative 3, which is negative 2 minus 1. Then I don't want to write the index in negative form, therefore we make it into A equals to 18t squared plus 8 over t cubed. Number 3. A particle moves along a straight line and passes through a fixed point O. Its displacement as meter is given by S equals to 8 plus 2t minus t squared, where t is the time in seconds when it starts moving. A, determine the expression for the velocity function V and the acceleration function A for the particle in terms of t. So from the displacement function to get velocity function, we do first derivative and we get 2 minus 2t. Then from the velocity function, again we want to get acceleration function. We will just derivative from here. So we get A equals to negative 2. Sketch graphs of displacement, velocity, and acceleration function of the particle for t from 0 to 4. Then interpret the graphs. So if you ask to sketch the graph, then we need to build a table, alright, for S. So when t equals to 0, sub into the S function, we will get S equals to 8, t equals to 1, S equals to 9, t equals to 2, S equals to 8, t equals to 3, S equals to 5, and t equals to 4, we'll get S equals to 0. And second, we'll need V, right? So V equals to 2 minus 2t. This is a linear function. Therefore, we need only 2 points to sketch the straight line. So we'll choose when t equals to 0, sub inside. So V equals to 2 minus 0, which is 2. And then when t equals to 4, we have 2 minus 2 times 4, which is negative 6. So, and since this is a straight line, alright, it will pass through the t-intercept. So, and we find that when v equals to 0, t equals to 1. Alright, so let's sketch the graph. Alright, so when we have s equals to 8 plus 2t minus t squared. In front of t squared, this is negative. Therefore, we have a set phase. Alright? So when we have a set phase with 8, 9, 8, 5, 0, okay, then we'll have a curve like this. So, name the graph. S equals to 8 plus 2t minus t squared. Then, we draw the graph V. Alright? So, when t equals to 0, we have 2. T equals to 4, we have negative 6. And this is the graph of V equals to 2 minus 2t, where the t-intercept is 1. Lastly, A equals to negative 2. Since A equals to negative 2 and negative 2 is a constant, so we'll have a horizontal line on negative 2 here. Now, interpret the graph. So when t equals to 0, we have s equals to 8, v equals to 2, and a equals to negative 2. Therefore, we know that the particle is 8 meter on the right of the fixed point O, because this is positive 8. With the initial velocity of 2 meter per second and a constant deceleration of negative 2 meter per second squared. Then, when t equals to 1, it happened for our maximum displacement, and then our velocity equals to 0, and the a is still negative 2. So, when t equals to 1, the particle reached maximum displacement at 9 meter with the velocity of 0 meter per second and acceleration negative 2 meter per second squared. So when t equals to 4, the particle reached a fixed point O because the s equals to 0. And with the deceleration of negative 6 meter per second and the acceleration of negative 2 meter per second squared. Alright, thank you.